Hi everyone, and welcome to our video on vectors. All right, so you might be familiar with vectors. If you've ever seen the movie Despicable Me, you might recognize this guy in orange. His name is Vector, and he jokes about how he's committing crimes with both direction and magnitude, and that's what vectors are. And in the movie, he even says that he's represented by an arrow. So when we talk about that in physics, it's really just an arrow. We might have an arrow like this, and we might say that this is a force or a velocity or something like that. But it's really just a way to kind of indicate which way is someone going. So for example, let's say someone says that they went 3 meters and then they went 4 meters. And then I could ask, how far did they go? There isn't really a way for you to know the answers to that. I mean, we might assume that they went 3 this way and then 4 this way, right? And obviously that would be equal to 7. And that's how we actually like add vectors as well. So one thing I want to mention here is what I just did there is I did a tip to tail addition. So when we add vectors, we want to add them where the tip of one is touching the tail of the next one. All right, but what if I didn't know which direction you're going? I mean, this could have easily been 3 this way and then 4 this way, right? In which case your total distance would not be 7, or sorry, your total displacement or how far you actually went would not be 7. What you would actually end up with is something that looks a lot like a 3, 4, 5 triangle, and we would say that your total displacement was probably only 5, right? So it really depends on the direction. So not only the magnitude, but also the direction. I mean, to give you one more example here, I mean, it's possible that you only went 1 meter, right? You could have gone 3 this way, and then you could have gone 4 this way. And so your total displacement would be just 1 in this direction, right? So this would be my 3, this would be my 4, right? But these are all different examples of how you would want to add vectors. You'd want to make sure that you're putting like tip to tail over here, right? And even over here, the best way to do it is just kind of like put the tail right next to the tip of the one that you just finished. Okay, so you have to give a direction for a lot of these numbers that are vectors, things that have a direction, like a distance or sorry, a displacement, a velocity, maybe even accelerations, forces. There's many things that are vectors. Okay, and then there even might be a situation where you're given a number and you can try to break it down into X and Y components. So let's kind of view an example that's a little bit different than what we just saw. But let's say I have a velocity and it's in this direction. And let's say it's like 13 meters per second. And let's say it's at an angle where theta is equal to like 20 degrees or something like that. So let me try to draw this line here, something like that. Okay. All right. And so 20 degrees, 13 meters per second in that direction, we can kind of figure out what are the X and Y components to this. So if I kind of try to draw this as a straight line here, right, we can try to figure out a Y component and we can try to figure out an X component. And this goes back to something that we talked about a few videos ago, which is just using our trigonometry rules. So I could say cosine of 20 is equal to X over 13. And then I can rearrange this and say 13 cosine 20 is equal to X. And then I can plug this, I can plug that into my calculator and I can get X. I can do the same thing for Y as well, right? So Y would just be sine of 20 is equal to Y over 13. Again, rearrange that equation and then you can solve for Y. And you can do this for multiple vectors. You can have this vector added to another vector that's at an angle, and you can keep on finding the X and Y components of each vector to find the overall movement in the X direction and in the Y direction.